Hi, everyone, and thank you for joining us for another great episode of Becoming Multiplanetary, one of the podcasts on the Total Space Network. Today, we have a special episode talking about future technology to sustain us, especially fictional technology. But before we begin, let me introduce myself. I am Kage, one of the hosts of this podcast, and I will now pass off to my awesome other co-host, RichLB.
Thanks, Kage. Like you said, I'm RichLB. I'm one of the other hosts here at Becoming Multiplanetary. And with that, shall we get straight down into it?
Yes, we shall.
So, a technology I'd like to bring up first, whilst it may not be useful in terms of sustaining us on Mars, I do think it's worth a special mention, and that is the warp drive taken from Star Trek. So, the warp drive at the moment, I think there was actually a physicist or a mathematician that actually tried to make a real-world equation on how it would work. His name is Miguel Alcubierre, and I will actually include a link to a video, a really wonderful video done by a YouTube channel called Event Horizon that goes, it's an hour long, and it's actually titled Can We Travel Faster Than Light with Dr. Miguel Alcubierre. It's definitely worth a watch, and it goes into the real-world physics behind how such a warp drive would occur.
Yeah, and it's really quite fascinating to see the things that Dr. Alcubierre put together for this. From my understanding, he kind of got the idea from watching Star Trek and thought, well, how could this be done in reality? And there's a lot of science that he put behind it, a lot of algorithms where he looked into what's called the ADM formalization of general relativity, looking at the space-time as described by a foilation of space-like hypersurfaces and a whole bunch of math that I honestly don't understand. But it's really incredible to see that, theoretically speaking, it is entirely possible that humans could, maybe, possibly, create a warp drive like you see in Star Trek. I mean, granted, it would probably take about the entire energy of the universe to do so, but there are some workarounds that have been discovered that could be possible if we somehow manage to find and utilize exotic matter. But that notwithstanding, the math kind of works. So that's pretty cool.
Yeah, exactly. Moving on to another technology, one that has been submitted by one of our staff actually, is the idea of Mars, as we know, has global dust storms, and when this happens, one of the main ways to make power, being solar, becomes affected by that. So you lose your visibility for sunlight, you lose your ability to make power. Now, there have been ways and means around this. Some people talked about bringing a nuclear reactor down with them and powering the systems using that as a temporary stopgap measure until the dust storm went away. There are some that say, okay, have a massive battery farm that would store energy as a reserve so that when you do have dust storms, you can draw on your reserves. But then you would need to be making more energy than you use in order to store up those reserves. One of the ways that it's possible to do it is space-based solar power. So there is a game out there at the moment that kind of simulates this. The Civ Beyond Earth game has a solar collector, which is effectively a giant solar panel in space, and the satellite beams down microwaves to collectors on the ground, and then they transfer it into power.
Yeah, there's a lot of really interesting technologies that have come out of the science fiction world, not only with respect to transferring energy, but also one in particular that I've really found most fascinating is one that's not only been seen in Star Trek, but also it was made famous in a lot of other works, including Orson Scott Card's Ender's Game, and that's the Ansible, where you have near instantaneous or faster than light communication. And that in particular would be really useful, especially when you're looking at potentially having humans on Mars, where it takes several minutes, I believe about 10 minutes, if I recall correctly, for communication to make it one way from Earth to Mars. And if you had an Ansible, if you were able to actually create something like an Ansible, then it would be entirely possible to even have like internet connectivity at a possibly reasonable speed between Earth and Mars. Not only internet connectivity, but the ability to communicate with base stations on Mars nearly instantaneously, as if you were talking to somebody just on the other side of the planet Earth.
I mean, they feature this in the game Mass Effect as well. There's a sort of communications room where you talk to the Elusive Man, and supposedly this technology works via quantum entanglement, the idea that you take a quantum particle one place in the universe and that it has its entangled counterpart somewhere else, and that by capturing the state of one, it instantly converts the state of the other. However, I'm not sure how feasible it is in real life to be able to transfer information in this way, but it is a neat idea.
Yeah, and we actually do already play with the idea of quantum entanglement here on Earth. For example, the LIGO gravitational wave detection units use a form of quantum entanglement to be able to detect if there are, for example, black holes that are colliding or neutron stars that collide and things like that. So it's still a very, very early technology, and our understanding of how to use quantum entanglement is maybe not even in its infancy yet, but there does show some promise that it might be possible to use something to that effect, or something we haven't even discovered that's related to it, to do something like an Ansible faster than light communication, which would just make so many things possible that were never thought possible before. For example, I don't even know how long it takes to communicate with the Voyager probes that are already outside of our immediate solar system. I think it's on the order of several minutes, maybe half an hour or more. And imagine if we were to send a probe out into deep space and we would be able to somehow communicate it near instantaneously. One of the problems with the New Horizons satellite is that they weren't able to communicate with that in any kind of instantaneous form. Once it was on its way towards Pluto, everything had to be pre-programmed on it. So if we somehow managed to solve that kind of a problem with an Ansible-like technology, then we would be able to, instead of only pre-programming satellites like that we could actually have some things pre-programmed, and then even in real time or near real time be able to, for example, start collecting some data, see that there's something really interesting there, and do a quick course correction to focus that spacecraft on that random thing that we observed, rather than try and predict what we might see, hope for the best, and get whatever we get.
So one of the other pieces of technology in Star Trek I'd like to talk about, because personally I think it'd be amazing if we literally had this device, and that's the tricorder. Being able to scan various things and know instantly what it is. Now, I know we have the technology to be able to scan various minerals at the moment and be able to get a result back, but to have one fit-for-all-purpose unit like a tricorder would be just amazing.
We do actually kind of have something to that effect nowadays. I mean, if you look at, for example, the communicators that were used in the early Star Trek series, those were kind of a maybe an inspiration for the flip phones of yesteryear. Anyone remembers the good old Motorola Razr and all those fun phones back then?
I actually worked in the mobile phone industry at the time when they were out, and the amount of returns we got were crazy.
Yeah, I can imagine. But not only that, we do kind of have some of those technologies already. I mean, there are, especially in the medical world, there are some scanners that do kind of have that ability to maybe not do what everything a tricorder could do, but at least some of it. One good example is that, especially nowadays in the pandemic that we're all surrounded by, There are handheld thermometers that you can use. Some of them, I think, use lasers. Others use maybe like a infrared beam to detect the temperature on the surface of your forehead or whatever part of your skin. There's a lot of kinds of handheld technology that exists nowadays. Maybe not too long from now, we'll have handheld tricorders of some variety that just merges a whole bunch of those. I mean, our smartphones nowadays do kind of have a lot of that ability. We have near field communication on smartphones, Bluetooth low energy. There's also various kinds of camera technology that exists, and all of that is just within a single smartphone.
Yeah, and there's actually a smartphone out there right now that actually does have an infrared thermal camera, and I believe it's the Cat S61, and that literally comes with a thermal camera. I was actually speaking about this earlier today. I reckon it won't be long in the current climate before we see most phones with these thermal cameras, with the way things are with the COVID pandemic at the moment. You know, a lot of people want to be able to see on thermal whether someone is running hot or not, to know whether anybody around them might have COVID-19 or what have you.
Yeah, that could definitely be a thing. I mean, this pandemic has definitely changed the world in ways that nobody ever thought possible, so who knows what it might do to technology. It's only been a little under a year, maybe about a year or so since this whole thing started. And yeah, I mean, it's entirely possible that we might see completely revolutionary cell phone technology that could, in some ways, be like a tricorder. I mean, it's not only thermal imaging, but if you look at, for example, some of the smartwatches that exist nowadays, or take, for example, the Apple Watch, it's able to not only detect your heart rate, but also, to an approximate degree, your blood oxygen level, can even detect atrial fibrillation. So we are kind of there, in a way, with tricorders, just in a different sense.
So what you're saying is the smartphone is more than likely going to end up being the prototype for the tricorder.
I mean, I think it kind of already is. It's, different than what was envisioned in Star Trek, but also in some ways not that different.
Okay, yeah. So out of the future technologies Kage, from all the sources you've seen, Star Trek, Stargate, whatever, what's the one that excites you the most?
Ooh, that's a tough question. I don't know. I mean, the ability to travel faster than light, so having something like a transporter or a warp drive or some sort of like wormhole travel, that's pretty cool. I don't know, for me, I think it's a toss-up between that and faster than light communication like an Ansible, because there's a lot of really great things that can come from either of those. The faster than light travel of like wormhole technology is maybe a bit beyond what we are capable to do in any realistic future for maybe several centuries at least. But faster than light communication, especially if we somehow manage to figure out how to make quantum entanglement work with that, that's something that could actually happen. And that could be an absolute game changer, especially for becoming multiplanetary on Mars or beyond. Or like I said, sending space probes deep into interstellar space and being able to communicate with them at a near instantaneous margin without any real delay. That would be revolutionary.
Oh yeah, and cycling back again to the whole becoming multiplanetary aspect of it, an Ansible would almost be an absolute precursor to any kind of galactic market if we wanted to trade across planets. We would need that kind of faster than light communication in order to be able to make real-time trades and stuff like that. Otherwise, a market wouldn't work very well.
Yeah, absolutely. And that would indeed be a foundational element for being able to have some sort of not only multiplanetary, but multi-solar system, multi-galaxy even, spread of humanity, and also interaction with other civilizations that exist out there, because without deep space communications to that effect, nothing really else is all that possible. I mean, take for example the latest Star Trek series. That, well, I don't know if I should talk about this in case people haven't seen the latest episodes.
Spoiler alerts!
Yeah, spoiler alerts. So if you haven't seen the latest Star Trek series, maybe skip a few minutes ahead. But one of the things that they mention in there is that there is something called the burn, where all interstellar travel got put to a halt, and not only that, but all interstellar communications got put to a halt. So it's not possible for Starfleet to communicate with the rest of their fleet beyond a certain distance, and it just completely shuts everything down. Without that ability to phone home, as it were, and communicate with the central command of an organization like that, it becomes practically impossible to maintain a sense of order to how things operate at that level. And it really demonstrates to me that having deep space communications, especially near instantaneous communication across a far vast expanse, is absolutely crucial to not only becoming multiplanetary, but becoming something far beyond that.
Absolutely. And the other thing that would arise from that as well, in terms of trading with Mars and that would imply that Mars then is an independent planet and has its own market and has its own internal trade and can trade on the galactic market, which would also help, improve and maintain diplomatic relations between the two as well.
Yeah, definitely. It's entirely possible that without one, Mars societies might become independent in a way, whereas with one, they might still somehow be beholden to Earth. That could really change everything. Even at something that's, relatively speaking, not that far away from us, yet still quite far. Far enough that that lack of instantaneous communication might make a night and day difference in terms of how things would develop if we were to live and stay on Mars and grow a society there.
Those are two very starkly contrasting scenarios there, It's a really, meaty subject to be getting into, for sure.
Definitely. Switching gears to a different Star Trek technology, one of the things I've always found fascinating, and we kind of have a little bit of that nowadays, is the holodeck. What are your thoughts on that one?
So firstly, we've got augmented reality, we've got virtual reality, and whether you want full immersion or whether you want just simply to augment the surroundings around you, you are right in that we have the first stages of this technology already. So with augmented reality, we know we can, for instance, pull up a heads-up display, very similar to how the badges in the latest Star Trek Discovery work. So whilst they may not be projected photons themselves, what we do have at the moment is simply an overlay passing over our eyes, which places things or projects things onto a 3D background, effectively. Now, with a holodeck in Star Trek, that was very much a full immersion kind of thing, where you were in a room, the entire room was projected, but the photons had mass somehow, and things were solid in such a way they managed to use some kind of photonic force fields, like microforce fields, to be able to create solid objects out of photons, effectively. And I don't think we really have that kind of level of advanced technology yet, but with enough research and development, who knows, one day we might do.
Well, we do kind of have a little bit of that. I mean, it's not exactly holograms, but I mean, if you look at, for example, the projected stage performances of Tupac Shakur, Michael Jackson, there are even ones of, I think, Gorillaz avatars on stage with Madonna, and there's also the I don't know their names, but the anime characters who will perform live on stage in before pandemic, sold out amphitheaters. Those were all hologram-esque kinds of depictions. They weren't actual holograms, but there is some technology there that we do kind of sort of have the ability to make something a little bit like a holodeck. Maybe not to the effect of the holograms can actually interact with you and touch you and you can touch them, but at least visually it does kind of trick the eyes.
But in terms of how this technology would help sustain us on Mars, for sure one of the scenarios I can think of is the long-term psychology of being in somewhere like Mars, if you're in an underground habitat or something like that. Being able, as Sebastian pointed out in the last episode of Becoming Multiplanetary, just being able to, walk into a room and all of a sudden be surrounded by nature, that alone could provide a lot of psychological healing for any potential candidate living in Mars if they are homesick or if they just need to feel surrounded by nature.
Couple that with some of the developments that were done years and years ago, maybe a couple decades ago at this point, with good old smell-o-vision, and you could even couple that with some sense of Earth. You walk into a holographic room, you have a beautiful, rich forest in front of you, and you can even smell it. That really would help with the psychological effects, absolutely. So, Rich.
Yeah.
Now it's your turn. What is your favorite fictional future technology?
Wow, as you said, that's actually a pretty difficult question. Me, I think the one I would be most excited for in terms of having a colony on Mars, hands down, has to be the replicator. And what I mean by this, yes, I know we have 3D printers right now, but I'm talking about replicating food and drink as well. Being able to sustain your colony using replicators. That, to me, would just be amazing.
That is actually a close third for me. One of the things that I think would be absolutely amazing too. And like you said, we actually are not that far from it. I mean, only in the past 10 years or so has 3D printing technology become something that practically anybody could have in their home. I mean, you can get an Ender 3D printer for a couple $100. They're not that expensive. And a whole lot of things are 3D printed. I mean, look at, for example, Rocket Lab. They just recently had a quite successful launch of their Return to Sender spacecraft, which came back and splashed down on in the ocean. And much of that rocket, much of the technology in that is 3D printed. That's something that not long ago, with not even half of our lifetimes ago, was thought to be practically impossible. So we're in the early stages of replicator technology, and there already are things that they don't only do 3D printing of plastics, but they also do 3D printing of metals. And there is some early development of 3D printing of biological materials, that perhaps we could 3D print pieces of flesh or organs even that could be used for transplanting. So it's entirely possible that in the not too distant future, we might have replicators of some sort.
In Japan, there are vending machines that can quite literally make you pizza and cook it on the spot. I don't know if you've seen videos of those.
I have. It could make you a Beyond Meat type of burger. It could make you various other things that's utilizing a clever mixture of proteins and other materials could give you something that has that flavor that might not be the same, but not far from it, and a little bit of a taste of Earth.
And I mean, this is stuff that you could theoretically do right now. We have hydroponics technology going to Mars. We already know that. And if you grow mushrooms or whatever other plant matter that they use in these burgers, then there's nothing stopping you creating this effectively meat paste from these plant matters and just tossing them in a 3D printer that has a superheater in the nozzle or something similar,
Absolutely. And a lot of the materials that are used for those kinds of foods probably, I imagine, wouldn't be that difficult to grow on in a controlled environment like you would have in a Mars habitat. I mean, a lot of them, like I said, are using soybeans or black beans, various protein compounds. These are things that could theoretically be possible to have and sustain and reproduce over and over again in a Mars environment.
So there we go, replicators done. Right, next. So, talking about future technology and talking about near instantaneous things as well, segueing a little to a slightly different franchise, Stargates.
Oh, it's one of my all-time favorite series. I love Stargate. I grew up on Stargate.
So, maybe perhaps not a Stargate itself, but do you reckon in sometime in the next few hundred years we could see some kind of wormhole travel technology similar to a Stargate?
Ooh, that's a tough one. I mean, that again is getting back to things like, well, wormhole technology, a Alcubierre drive, a whole lot of things that are quite difficult to conceive of, let alone even produce. So, I mean, I would love to see it. It's just a matter of how could we get there?
For sure. I mean, we've got some mathematics that cover the basics of how to do a warp drive, and for those who aren't familiar with the work, effectively, the way I like to analogize how this warp drive works is imagine you have a toy car. Now, when you move this toy car, normally you put your hand on the top of the toy car and you use your hand to move the car. Some cars have a mechanic whereby you can drag them backwards, it coils up a spring, and the spring then propels them forward. Now, the idea of this warp drive is you're not actually propulsing anywhere at all. What's happening is you're contracting the fabric of space-time in front of your vehicle and extending the fabric of space-time behind your vehicle. And a really great way to visualize this is if you're at home and you have a rug and a toy car, if you were to put the toy car on one end of the rug, lift the rug slightly and just give it a flick with your wrists, it will create a wave along the rug that the toy car will be propelled along with. And that is essentially what Alcubierre's theory proposes in a nutshell.
You know, there's also one technology that is seen not only in Star Trek, but also in Stargate, and so many other science fiction series, and that is cloaking devices.
Yeah, I think I've seen something recently which some people have managed to accomplish, not quite exactly a cloaking device, but it's a type of it's a pane of some kind, and it's made of some kind of nanomaterial or something like that. And what it does is it manages to obfuscate light in such a way that all you can see is some kind of frosted transparent pane. You can't actually see what's behind it.
Yeah, so there actually have been some successes, I guess you could say, minor successes, but some successes nonetheless in producing cloaking devices in the real world, where, for example, the ability to obscure objects within a certain segment of electromagnetic spectrums. There's, for example, the use of metamaterials, which are materials that are artificially engineered to have properties not found naturally occurring. There's actually a lot of research that's gone into that, especially in the last 10 years, where they have managed to produce some kinds of active camouflage technology that can distort images, especially when you're looking at something with a camera, where it has like a CMOS sensor or something to that effect. Not quite there yet for tricking human eyes, but there actually has been some success, at least a little bit.
You know, something that makes me chuckle to myself about this type of technology is we actually have a natural example of it in space, in that of gravitational lensing. Are you familiar with it?
Yeah, it's also even used to kind of see things that would be otherwise impossible to see, especially with things that are very, very far distant. For example, using gravitational lensing to be able to see through a cloud of dust.
Yeah, and I know that some people tend to use gravitational lensing as well to measure how far an object is behind something like a black hole, which is what causes the gravitational lensing. And from that as well, there could be applications for stealth technologies using some kind of gravitational well technology on a spacecraft as well. You could generate a graviton field around you, and that would help obscure your ship.
Yeah, but now we're getting into the realm of artificial gravity, which is another really interesting future technology of, rather than using something like, I believe it would be centrifugal force, but I might actually have that force wrong. Rather than using something to that effect to make a form of gravitational effect for people traveling in deep space, there's also artificial gravity, which, if you're getting into the realm of gravitational lensing, you're probably sooner going to get into the realm of being able to just create artificial gravity itself, in which case we've probably already advanced to the point that we could find some other forms of camouflage or cloaking device technology. We might not even need to use gravitational lensing for that.
So, theoretically speaking, anything that has a large amount of mass emanates gravity, right?
I mean, I think so. There's a lot of competing theories about what actually is gravity.
So, theoretically speaking, if you found a substance that had quite a dense mass, then you could generate some form of light artificial gravity.
Possibly, yeah. But Veritasium actually did a video recently on YouTube about what is gravity, and at that point, yeah, you're talking about having something where you have a huge amount of mass condensed into a very small area in order to bend space-time, in effect, which, as far as I understand it, is one of the competing theories for what gravity is. It's possible then that you could even have something to that effect. I mean, if you're able to pack that much density into a small surface, that you could use that for producing artificial gravity. Well, actually at that point it wouldn't be artificial gravity, it would be real gravity, I guess. But also use that for making your own kind of gravitational lensing, perhaps.
Yeah, I mean, you could totally do that if we found a substance which had enough mass. Then yeah, the only issue then is if the substance that you found had that much mass and it did cause its own gravity, would it cause a structural integrity situation on your ship?
So what's the densest thing that we can produce currently? I think probably tungsten. Is there anything that we can make currently that's even denser than that?
I'm not entirely sure. I know that in terms of mass, some of the nuclear materials have quite large amounts of mass.
Okay.
But the only issue is obviously they're not stable.
And there is that tiny issue of radioactive decay and the cancer it can cause and everything else that comes with that.
Just a little issue. It's not a big one. It's fine.
Smallest issue, just a little tiny one.
In terms of sustaining a colony on Mars, then, let's talk a little bit about mining the resources, the in situ resource utilization. In the likes of Star Trek, we see a lot of mining worlds where effectively the entire world is just one big mining colony, more or less. And right now we do have some good mining technology that we use on the seafloor, in Earth, and in oil wells, wherever they are across the globe. So in terms of getting to Mars and mining the resources, what are your thoughts on that?
It wasn't just Star Trek, but also a really, really good TV series, a recent TV series called The Expanse, also touched on that. You even had entire societies that were based around being miners in areas of the outer solar system, the belters. And it's absolutely necessary in order for us to be able to sustain life on Mars. I mean, look at, for example, the current Mars Direct 3.0 strategy from Miguel, who was on our show recently, and also some of the plans that SpaceX has had for being able to stay on Mars and get off of Mars, that they would have to mine the surface for materials in order to produce methane and oxygen. Otherwise, they're not going to be able to have enough fuel, and they're stuck there and they die there.
For sure. And, we're going to have massive advances in this technology when it does start getting used, because what's going to happen is they're going to start putting that machinery down, and there's going to be situations that they may not have anticipated and that they're going to have to engineer around. And that alone is going to give progress in that field. So that when, and some of the progress that they make in that field might even be applicable back home on Earth as well.
Not only that, but also kind of looking more realistically in the near future, there's also some ideas of doing that on the moon. So the SpaceX, for example, with their moon version of the Starship, they're looking into some potential ideas of mining the surface of the moon in order to extract water and other materials in order to produce fuel and produce potable water that humans can drink, that can be used for other purposes, and then whatever other materials they could mine on the moon. And in fact, it is indeed true that the moon would be a good practice ground for the ability to sustain life on Mars, because there's nothing to protect you on the moon. If you're able to survive on the surface of the moon, if you're able to mine materials from the surface of the moon, refine those, and use those for fuel and other purposes, why couldn't we do the same on Mars?
I mean, sure. And another thing from that as well is, when the mining does occur on Mars, are we going to see it first with human hands, or are we going to see some mining drones where we have these drones that are specifically sent to mine a certain amount of each material so that the humans that land have some kind of starting pot, as it were?
I mean, why not both? Of course, send some automated machinery to do it first and get you a head start. But I don't see any reason why humans couldn't also do the same. I mean, practically speaking, if you look at technology here on Earth, for coal mines here on Earth, we have a lot of things that are automated. You have longwalls, for example, that do a lot of the drilling and extraction and material separation and a whole lot of other operations there that is mostly automated, but it still requires humans to run it. That said, you make something automated to that degree for purposes on the moon or on Mars, that's also something that could be done here on Earth. And then you wouldn't have as much of a danger factor for extracting materials like that from underneath the surface of the Earth. Granted, we probably should slow down on extracting those kinds of materials from underneath the surface of the Earth, but that's another topic. So yeah, there are a lot of really interesting technologies in the science fiction world, and even some that we have already explored a bit. And that's not even touching on some of the other things that we haven't talked about yet, like tractor beams and transporters and all the various kinds of plasma energy weapons and drilling materials and so forth. That there's a lot of things out there that are really fascinating, and if we can get closer to some of those, that would be absolutely revolutionary to making us multiplanetary. So with that, I think it's about time to wrap up. I am Kage. I have been your host for Becoming Multiplanetary. Thank you so much for joining us. If you'd like to check out our other podcasts on the Total Space Network, please check us out on totalspace.net. You can also find us on Anchor FM/Total Space. If you would like to join us in our Discord for exclusive ability to listen to us while we record these podcasts and also catch all of the bloopers that we make during the process, check us out on Patreon. That's patreon.com/totalspace. And with that, I will hand over to my co-host, RichLB.
Hi guys, RichLB here, also another host here at Becoming Multiplanetary. Thanks for listening to the episode this week. Stay tuned to our Twitter channel. I'll be announcing next week's episode sometime during the week there. And hope to see you again for next week's episode of Becoming Multiplanetary.
Oh yeah.